This is the review for exam 2. I'll be able to take some questions there at the end. You can like be thumbing through and looking for problems that, or there's a concept that we hit here and you want another problem done, grabbing your book, looking through it to one of the ones that we assigned, going that route, or one from past problems that we've done in class. But when we're looking at a problem like this, and all these review, they're not necessarily in order of the book, because the test doesn't necessarily follow a chronological order either. So we just want to get you in the habit of doing that. And by the way, all right. So here, this is already factored. Common mistake is people are going to go and look at this and say, oh, I need to FOIL this out, and you would be actually defeating the purpose. Here I'm looking and saying I have two things. I've got this thing multiplied by this thing, multiplies to 0. And that means either 2x minus 1 is equal to 0, or x plus 2/3 is equal to 0. So 2x equals 1, x equals 1/2. Here, x equals negative 2/3 for the two answers that go into that. When in doubt, you can always go back and plug it in to see if it actually makes your equation 0. So if you put it in here, the 1/2 in for 2, 2 times 1/2 is 1, 1 minus 1 is 0. 0 times anything is 0. Negative 2/3, negative 2/3 plus 2/3 is 0. 0 times anything is 0. This will be more probably what you're going to be looking at seeing, where it's not yet factored. And then you're going through all the steps of factoring. So you're thinking GCF is typically the place I always start. And how do I know that I'm factoring and not doing something else? I have an equal sign, so I need to solve this. It's got a power greater than 1, so I'm going to set it equal to 0 and then run through my steps. So GCF, yes, 4x can be factored from both of them, leaving me with x squared minus 9 equals 0. 36 divided by 4 is 9. And then I go, oh, I've got a quadratic here in the middle. I'm going to see if there's a way that I can factor that. Don't lose track. The 4x is still out in front. And then you recognize that this is a difference of squares. If you've been doing the online quiz review, you'll notice that that's one of the questions that's on there that asks which of the following are. And you'll be seeing several of them on the exam as well. That's why it's mentioned many, many times. The reason why, if you're wondering why do I emphasize that so much, you could theoretically take this and say, well, 4x, when does that equal 0? Well, that will equal 0 when x equals 0. And you could take this and say, well, when does x squared minus 9 equal 0? And we did some of these in class the other day. Common thing is people go, well, add 9 to both sides. X squared equals 9. And then the inverse of squaring is square rooting. So I'd have x equals 3. But the problem is you miss one of the answers. Because when we factor it down here, as a difference of squares, we'll see that, well, this is 0 when x equals 0. This is 0 when x is negative 3. And this is 0 when x is positive 3. So if I were just to jump with this one straight to setting it equal to 0 using the square root, many people forget that when I take the square root of something squared, it should be plus or minus. So now, what I really want to do is find my common denominator. I have, and when finding a common denominator, if I can, I'm going to look and say, can I factor this? Because it's a squared, I have a difference, subtraction, of squares. This is 3 squared, that's a squared. So this factors into 3 minus a and 3 plus a. And that looks similar to these, but slightly different. This one, 3 minus a, is almost like a minus 3, except my negative is in the wrong spot. So what I can do from this set of parentheses is I can factor a negative out of them. factor a negative out of them. If I factor a negative out of positive 3, that leaves me with negative 3. If I factor a negative out of negative a, leaves me with positive a. And then a plus 3 is the same, or 3 plus a is the same as a plus 3. So then I look at these other two and I realize that they almost have the same denominator. What do I need to do to make this denominator look like this denominator? I need to multiply 2a over a minus 3. I need to multiply it by 1. And that has the same value as 1. The second one, I have an a plus 3. I need an a plus 3 and an a minus 3. So I'm going to multiply this fraction by 1. I keep grabbing the wrong tool. There we go. 6 over a plus 3. I'm going to multiply it by a minus 3 over a minus 3. And it will equal what this original part was up here, which will be 28 over, I'm going to put that negative way out in front. It doesn't matter where it goes. Once I do that, I can look at this denominator and say they all now have the exact same denominator, which means if all of this is going to be equal and they have the same denominator, then the numerators, I should include the negative because that's part of this equation, then the numerators must be equal. And then that's where I actually will get my problem that I'm going to work out and do. So I'll have negative 28 equals 2a, a plus 3, plus 6 times a minus 3. So again, at that point, I can not ignore the denominator per se, but I no longer have to consider it when I'm solving this equation. I will come back at the end because I need to verify some things. But now, let's 2a squared plus 6a plus 6a minus 18. I'm going to do two things in this next step. I'm going to add the 28 to both sides and simplify. Move that up and out of the way. And I'll have 0 equals 2a squared plus 12a plus 10. Negative 18 and 28 should be 10. And now I'm back to a quadratic. Need to factor it. Looking for a greatest common factor first. I could do completing the square, but this hopefully will be faster. Completing the square, sorry, I said complete, I meant factor by grouping. Similar idea. Now, I'm looking for two numbers that multiply to the last, that multiply to 5, and add to 6. Multiply to positive 5, add to positive 6. This 2 is still in front. A plus 1 and a plus 5. My two answers. What makes this whole thing 0? Can 2 ever be 0? Nope. Can this ever be 0? Sure. When a equals negative 1. The second one when a equals negative 5. Last thing in a problem like this, since my equation started out with a big thing with a fraction, so lots of denominators, we remember, hopefully, that you can never have 0 in the denominator. So you'll want to check this. If I have negative 1, does that make this 0 in the denominator? Nope. How about this one? Nope. And since they're all either 3 or negative 3, so neither of these will make 0 in the denominator, so both are possible answers. If I solved the numerator and I found one of my solutions was x equals 3, I would say, well, I can't do that one because 3 would make the denominator 0. So while it would make the numerator 0, it would make the denominator also 0, and I cannot have 0 divided by 0. 0 divided by 0 would be undefined. If you're wondering back to when I asked you the question in the discussions a long time ago, when you looked at 0 over 0 and 0 to the 0, 0 divided by 0 is undefined. 2 solutions. There we go. We just did these recently. Process when dealing with square roots is get the square root all by itself on one side. So you can either take this x and the negative 5 and move it over, or I can take the square root and move it over. I'm going to actually, because it's only one step, I'm going to add root x plus 1 to both sides, leaving me with, on the left, x minus 5 equals, on the right, root x plus 1. Once I've got my square root all by itself, I need to then get rid of the square roots. And the process for getting rid of square roots is squaring. Here, make sure you put parentheses on it, squaring. Squaring means times itself. So that's what that means. So if I want to get rid of that. So on the left, I'll have x squared minus 10x plus 25. On the right, I'll have x plus 1. And I did FOIL really fast on the left-hand side. You may or may not do it that quickly. Being careful to not just call it x squared plus 5, or 25. There is a middle term when you FOIL it out. And now I've got a quadratic. And as we've done what feels like probably 100 times or more, should be, especially if you've been doing the check your understanding, it's been way over 100 times. We're going to set this equal to 0. So on the left, I'll have x squared. I will have negative 11x when I subtract an x. And I'll have positive 24. And then is there a number, 2 numbers that multiply to positive 24 that add to negative 11? Well, if they multiply to a positive and add to a negative, they must both be negative. 8 and 3. 8 times 3 is 24. Negative 8 plus negative 3 is negative 11. And then since I've been doing this a bunch, I say, well then x equals 8 and x equals 3. If I want, I could check these back up into the original equation. 8 plus 1 is 9. Square root of 9 is 3. 8 minus 3 is 5. Minus 5 is 0. Do the same thing with 3, and I could check that one to see that that also works. Good morning. As we carry on, we have more fractions. To work fractions, I want to have a common denominator. When there isn't one written, it's not a bad idea just to throw it over 1. Common denominator is going to be 8. That means this fraction was multiplied by 4 over 4. This fraction was multiplied by 4 over 4. This fraction was multiplied by 8 over 8. So when I do that, I'll have 8 in the denominator for all of them, which means I will only have in the numerator 4 times x plus 5 plus 4 equals 16x minus x minus 3. Common mistake is people will forget that there's a parenthesis on this whole thing. I'm subtracting the whole fraction. So if I'm looking just at the numerators, it's minus that whole thing, x minus 3. Minus a negative 3. So 5x equals 19 minus 24. Negative 5. X is negative 1. When dealing with absolute values, now this absolute value should have been a taller, just so we can see that's the absolute value of that whole thing. Process is, much like square roots, get the absolute value all by itself first. So absolute value of x over 3 minus 1 will be greater than or equal to 2 when I add 7 to both sides. Then, when I drop the absolute value, I have to include the other end, which is the sign pointing in the same direction. And whatever's on this side is negative on that side. How come? Because this inside here could be positive or negative to give me a value of 2. So 2 or negative 2 would give it to me. So the negative 2 is over here. And because it's not equal, it's a inequality, I keep the same direction, I should say. So negative 2 greater than or equal to this, greater than or equal to 2. And then what you should do is reset it as 2 different equations. Negative 2 greater than or equal to x over 3 minus 1. And then over here, x over 3 minus 1 greater than or equal to 2. And then run them through individually. So this will be add 1, so negative 1 greater than or equal to x over 3. Multiply both sides by 3, x greater than or equal to negative 3. Or sorry, negative 3 greater than or equal to x. On the right side, x over 3 greater than or equal to 3. Multiply by 3, x greater than or equal to 9. My 2 values are negative 3 and positive 9 on a number line, so I'm looking at negative 3 greater than or equal to x. So x is at the pointy end, if you will, so it's on the small side, which means the x is less than negative 3. So that one would shade over this way. And it would be a closed dot at 3 because it's less than or it's equal to right there. X greater than or equal to 9. Greater than or equal to means it's above. Shading up. Closed dot at 9 as well because it's a inequality with an equals. Greater than or equal to or less than or equal to. Closed dots. So any number theoretically that is down here, any number that is up here should make this equation true. That goes into that. Here we're dealing with 2 aspects of what we've covered so far. From the first exam, it's dealing with the laws and properties of exponents. All right. From more recently, since the last exam, it's dealing with what do we do with roots of various types, and what do they mean? If I have just a 4th root of something, that would be the same as writing it as a to the 1/4 power. So roots are fractional exponents. So with this one, I'll have x to the 4th, y squared over 16, z to the 8th. And the whole thing is to the 1/4 power. All right, so that's what, as you're trying to figure out, like, what do I do with this and how do I set it up? That's one of the aspects in terms of, as I'm grading through and working through these problems, what I'm looking to see is, did you recognize and remember that a fractional exponent is the same thing as a root? So in this case, the fraction's a 4th, so it's the 4th root. All right, and then the other thing that we're trying to recall is if I have b to 1 power, and that's raised to a higher power, powers raised to powers get multiplied. So it'd be b to the a times c. So in this case, I'll have x to the fourth times a fourth, y squared times a fourth, 16 to the 1/4. So there is no exponent on the 16, but there is. We typically don't write it, but it's 16 to the 1 power. So it's 1 times a fourth. That's why it's 16 to the fourth. And then I'll have z to the 8th times 1/4. Four times a fourth is 1, so I'll have x. 2 times a fourth is 2/4. Let me erase this so it's out of my way. So that'll be y to the 1/2. 16 to the 1/4. Is there a number that I can multiply by itself 4 times to get 16? 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 is 2 or -2. Again, because if I take 2 to the fourth, I will get 16. If I take -2 to the fourth, I will get also 16. So it'll be plus or minus 2. And then z, 8 times a fourth is 8/4, which is 2. As long as my exponents are positive, this would be considered simplified. I could rewrite it if I wanted to as x times the square root of y over 2z squared. When you see my 2's and z's next to each other, you understand why I crossed my z's, because they look the same pretty much otherwise. And then I gotta not forget, I'll erase my equal for a moment, make it over here further. It's plus or minus the whole thing, because either of the two will give me an answer. How will I remember that it's going to be plus or minus? When you're taking even roots of numbers, you need to be considering it could be positive or negative. Square root of 9 could be 3 or -3, because -3 squared is 9. So square root, fourth root, sixth roots, eighth roots, we're not going to have ones like that. Those numbers get so big that I wouldn't expect you to be able to crank those out by hand. And then other times people say, well, can I do this in my calculator? Absolutely can, depends on the type of calculator you have. But if I take 16, so if you're working with like a graphing calculator, 16, and you do caret, and then parenthesis, 1 divided by 4. All right. Or you can remember that 1/4 as a decimal is 0.25. So if you have a less sophisticated calculator, you could go 16, and then you would hit like the X to the Y button, and then you'd type in 0.25. Your calculator, though, is only going to give you the positive number. It's only going to give you 2. So again, depends on what kind of calculator you have as to how you would type that in there. Graphing calculators like this, 16, then you press the X to the Y button, and then you type in 0.25 and then enter. That 1/4 shouldn't be in my box. All right, I'm going to divide. I'll be asking you to do division 2 different ways. One will be using long division. One will be using synthetic division. So this one's set up like this. The third way you could do it is you could just factor and then do some reducing. So if I start with that, do factoring, just because we're going to have a lot of factoring that goes on through the rest of this course. I look to my numerator and say, is there something in the numerator that can be factored out of all 3 terms?
5.
Absolutely. Anything else? X. Anything else? Nope. So then I'll have x squared minus 2x squared, because 10 divided by 5 is 2. X cubed divided by x is x squared. Negative 5 factors out, so I just have negative x. And then I'll have plus 4. In the denominator, I will have x minus 5. And then over here, I'm going to take and do just the 2x squared minus x plus 4, a times c, which is 2 times 4, which is 8. I need two numbers, if they exist, that will factor to 8, multiply to 8, and add to negative 1. And there aren't any. So since there aren't any, then the factoring method won't work. And you might say, well, then I just wasted some time. Not necessarily. If it factors, it's actually your faster way. So then I'm going to go ahead and set it up as long division. 10x cubed minus 5x squared plus 20x plus 0. When you're doing division, you have to include all the terms. So if there were if there was a x squared that was missing, it went 10x cubed plus 20x, I'd have to have a 0 in this spot. I'm going to divide this by x minus 5, and then it's using properties and principles of long division that you possibly learned long time ago. And I'm looking to see x times what gives me 10x cubed. X times 10x squared. And then I take 10x squared times x, which is 10x cubed. 10x squared times negative 5, negative 50x squared. 10x squared times negative 5. That's where that one comes from. There, and I subtract. 10x cubed minus 10x cubed is 0. If it's not 0, you did something wrong, because in division, you have to do something that gets rid of that first term. So when I multiplied there, you'll also notice that the 10x squared is above the squared column. I don't put it above this one. Put it above the squareds. All right. Then I have negative 5 minus negative 50. That would be positive trying to get back to my, there we go. I'll just do it in that color. It'll be positive 45 x squared. Bring down this one, 20x. Now I need x times something that will be 45x squared. So up here I will have positive 45x. So a positive 45x times x is 45x squared. Positive 45 times negative 5. This is a positive here, by the way. Will be negative, and 45 times 5, 225. Am I multiplying right? 25 carry the 2, 22. Yes. There we go. Subtracting 45x squared minus 45x squared is 0. 20 minus a negative 25, 225, so that'd be plus a positive. So that'd be 240, so 200, yes. 245x. Bring down to 0. I need to get this to multiply to 245x. So this will be plus 245. So this will be 245x minus, and now I need someone with a calculator to tell me what's 245 times negative 5. So that's 1,225. I subtract. This subtracts to 0. I have minus a negative, so it'll be plus a positive. So my remainder, when I'm done, because I ran out of things here, so my remainder is 1225. So we write it as plus 1225 over x minus 5. Now, if you're doing the online quiz, I have you do long division or synthetic division. However you do it in your notebooks, I think I asked you, like, just enter the remainder. And then you would put the remainder in there as a typed number when you're working on that problem. So, and the remainder would be just, what I'm talking about is I'm talking just that number. Obviously, you wouldn't put in over x minus 5. You just plug in the number. What's the number remainder? All right. Simplifying fractions within fractions. Try to start, we're just going to take this one over here and do that first. So x over y squared plus 1 over y. My common denominator will be y squared. So that means I need to multiply this one by y over y. Right? Multiply it by 1. Doesn't change the value, just changes how it looks. So it'll be x over y squared plus y over y squared, which will be x plus y over y squared. All right, going to kind of put a pin in that and come back to that in a moment. Let's take this one over here. Y plus x, y over x squared plus 1 over x. This needs to be then times x over x to get a common denominator. Y over x squared plus x over x squared will equal y plus x over x squared. So if we bring them back together, in the numerator, I had x plus y over y squared. In the denominator, I had y plus x over x squared. Dividing by a fraction is the same thing as multiplying by a reciprocal. Oops, sorry, I didn't mean to move it that far. So this equals x plus y over y squared times x squared over y plus x. And then here, I'm looking at this, x plus y and y plus x. Are those the same thing? Is 4 plus 2 the same as 2 plus 4? Is negative 4 plus 2 the same as 2 plus negative 4? The answer is yes. So addition is way back, way back. You gave names. This is commutative, which just means they can go in the other order, like they can commute back and forth. So I could rewrite this or recognize it, but either way, it's the same thing as x plus y. They're in fractions. I like to put parentheses around them so I remember that they're together. But they are identical as I multiply the numerator, multiply the denominators. They are identical numerator and denominator. When you have the exact same thing in the numerator and the denominator, and I'm multiplying or dividing, they can reduce. I'll have then 1 times x squared over y squared times 1 for my final solution of simplifying that fraction up top. Here I'm going back to just simplify, which is remembering all of these things. Doing your parentheses first. Here I'll have in the denominator negative times negative times negative. Be negative. 5 times 5 is 25 times 2 is 50. My numerator, I'll have 6 times negative 8, and then minus 2, because plus a negative is minus. In the denominator, I have negative 50. In the numerator, I'll have negative 48 minus 2 over negative 50. So I'll have negative 50 over negative 50, which is 1. That was nice. Common mistakes, negative 2 cubed. Either people do negative 2 cubed and get a positive 8, which would be incorrect, or they go negative 2 times 3 and get a negative 6. That's more wrong. So just forgetting that the negative stays a negative as an odd power, that's a minor mistake. Negative 2 times 3 is a much bigger mistake. I want to say the last time we had class, we went through a problem very similar to this one. Suppose you were standing on a platform 48 feet tall. You might wonder, yeah, that's what the recognition is of that number in there. Because when time is 0, you're at 48 feet. All right, and the ball has an initial velocity of 32 feet per second. Yep, that's that number there. Vertically up in the air. If the height of the ball after t seconds is expressed by this function, h of t, which means the height with respect to time, where t is squared, this is the velocity, this is the height, this is the constant of gravity, negative 1/2 gt, negative 1/2 g, the t squared's right there. But it says find the time when the ball will hit the ground. Hint, the ground is when the height is 0 feet. So I'm asked to find out, well, when is this going to equal 0? Now it's like a quadratic. First step in quadratics is there a GCF? Are all three of those numbers divisible by the same thing? I see some nods. The answer is yes. They're all divisible by, pick a bigger number. 16. I'm actually going to factor out a negative 16. And the reason why is that'll leave the t squared positive. But that means the middle number is negative 30. No, not negative 32. Negative 2, because 32 divided by negative 16 is negative 2. And then the 48 will be negative, and that will be 3, because 48 divided by negative 16 is negative 3. If I can factor out the negative, then I can look and say, is this going to be t and t? Two numbers that multiply to negative 3 that add to negative 2. Well, they multiply to a negative, which means one of them is positive. Oh, I didn't mean to do. There we go. One of them is positive and the other one's negative. And they add to a negative number, which means the bigger one has to be the negative one. Those are the only two numbers that multiply to 3. Negative 3 and positive 1. Do they add to negative 2? Negative 3 plus 1. Yep, that's negative 2. That works. So my 2 times that make this equation equal to 0 are t equals negative 1 for that first set, and t equals 3 for the second set. And then a final aspect would be recognizing that in context, I cannot have negative time. So when will the ball hit the ground? 3 seconds after it's launched. Does this look familiar? Something very similar to almost identical was on the first exam. And I'm covering it again. Interesting. All right. Typically does not mean you all got it right, no. On Monday, they sold a total of 25 items, muffins and croissants. So muffins plus croissants is 25, because that's how many items you sold. Then we have a second aspect to this, which is dollars. So muffins are $2, croissants are $5, and if we add those up, I earned $86. How much of each did I sell? So one, you set up the problem, and then two, you recognize, 2 equations, 2 variables. I can solve this by graphing, substitution, linear combinations, or matrices. The choice is yours. In a case like this, since all of these coefficients are 1, typically, if I take this and multiply by, let's multiply by -2. If I multiply by -2, I'll have -2m. So I'm going to take this one, multiply by -2, and then we're going to write it underneath this one. So it'll be -2m minus 2c equals -50. Everything got multiplied by -2. And now I can add these 2 equations together. 3c equals 36, c equals 12. And since c was 12 and they add to 25, m plus 12 is 25, m is 13. There were many people who tried guess and check to get to an answer. So you got to the right answer, but I believe I even said on the exam, guess and check is not a viable option. So you got the right answer, but since you used guess and check, there were no points awarded. Here I say use synthetic division. Because that would have been, if this had been written like this, I'll change my color here. If this had been written like this, y minus 3, that's the same idea. But if you're told synthetic division, then I have to set it up and do it by synthetic division. Synthetic division is I take the coefficients in descending order, cubed, squared, y to the first, and then a constant. There's nothing missing, so I can write them just in order. 4, -12, -1, +12. And the number that goes over here is the number that makes this 0. So the root, or the 0, as it's called, that's the number that goes in this little box. All right? When we did regular division, we did the whole y minus 3. And then when we did division, we did subtraction. And I said one of the great advantages of synthetic division, 1, it takes up way less space. But 2, it uses addition instead of subtraction. So that means I have to use not this number, not the -3. I use what makes this 0, which is +3. All right. Process is I bring the first one down, and it's 4. 3 times 4 is 12, and that goes back up here. And it's a +12. And again, the process here is I'm adding up every time. So I add those up, I get 0. Oop, didn't mean to go green. 0. Then I go 3 times 0, and that goes in the next spot. 0. And then add -1. 3 times -1 goes here. -3. and then add, I get 9. And then I'm done. I stop right there. I was originally cubed, so this would be y squared plus 0y minus 1 plus 9 over y minus 3. That's my remainder. Or realistically, I'd write 4y squared minus 1 plus 9 over y minus 3. That's a 9. And that's how I'd finish it out for using synthetic division. So synthetic division was the same thing as regular division, which is the same thing as factoring, which would be that. So then if I wanted to, I could take this and I could go y times this and y times that and y times the last thing. Negative 3 times this, negative 3 times that, negative 3 times this. And I would get the original values up top. So factoring, division, synthetic division, all serve the same purpose. Direct variation and inverse variation. Y equals kx is direct variation. Y equals k over x is inverse variation, where k would be some type of constant of variation. This says that u varies inversely as w. U, that's a mu, sorry. U varies inversely with w. And then I need to have some constant, some number. So that's the initial setup. Then plug in values. It says when, or if u is 3, when 2 is 5, that's probably supposed to be a w. That would make sense, because I don't have a 2 anywhere. When w is 5, there we go, shaded in. Find the constant of variation and the inverse variation equation. So first thing I gotta do is find the constant of variation, which means I gotta solve this for k. Multiply by 5, k equals 15. So my equation would be u equals 15 over w. So then if they give me any future u's or w's, I could use this equation to find the other one. Now, the day we presented this in class, we used Boyle's law. Constant gas constant PV equals nRT, and we did a whole bunch of combinations thereof. All right. Ooh, more massive fractions within fractions. I'm going to do this one over here first. 1 over 16, it's not 1, it's x over 16. Minus 1 over x. My common denominator will be 16x. So this needs to be multiplied by 16 over 16. This one needs to be multiplied by x over x, which will leave me in the numerator with x squared minus 16 over 16x. Take this one over here. 1 minus 4 over x. The 1 needs to be multiplied by x over x, which will result in x minus 4 over x squared. Because x times 1, that's a minus. Make sure it doesn't look like a multiply. I'll have x's in the same. Oh, sorry, just x, not x squared. Because x times 1 is x, and this is an x, so I'll just have x in the denominator. So that's my whole denominator. So I'm going to rewrite my fraction as x squared minus 16 over 16x all over x minus 4 over x. Dividing by a fraction is the same as multiplying by the reciprocal, so I'll have my numerator, x squared minus 16, divided by 16x, times the reciprocal, so flip my denominator. And then because we've done it about 1,000,000 times, not really, x minus 16 is a difference of squares. It factors x plus 4, x minus 4, and then it's just being multiplied by x, so times x. My denominator, I have 16 times x times x minus 4. Again, just multiplying across on fractions. And then I look for, is there anything that's identical numerator and denominator that's being multiplied only that I can reduce? I have an x that's being multiplied. I have an x that's being multiplied. They can reduce. X divided by x is 1. X minus 4 divided by x minus 4 is also 1. Leaving me with the final answer of x plus 4 over 16. And then always wondering, is there anything else I can reduce? A common mistake would be to say, oh yeah, you can reduce these. You can't do that. The only way you could reduce these is if I split the fraction up. So if I unsimplify this to x over 16 plus 4 over 16, see how I just split it into two different fractions? Then I could. Then it'd be x plus x over 16, and then this over here on the right would reduce to 1/4. But ideally, this is where I'd look for you to stop. If you did this, that's nothing wrong. I would not consider it wrong. It would just be an extension that you didn't need to do. So the ideas that I'm grading on as you're looking through this is simplifying with common denominators, reminding yourself that dividing by fractions is multiplying by reciprocals, recognizing difference of squares, factoring, and reducing. So that one problem there covers like 4 chapters out of this textbook. And that's why I like problems like this, because it really gets me going and figuring out where you're at and what you're doing. And then jogging the Wayback Machine in our memories. If I have write the equation of a line parallel. When I say parallel, you need to be thinking in your head, parallel means same slope. Parallel means same slope. Well, that means I need to take this equation and find the slope of that equation. And unless you remembered and memorized a formula for doing it, most people have to take that and solve it for y. Subtracted 2x from both sides. Divide everything by -3. And then I would say, the slope of this equation is 2/3. Y equals mx plus b. Which means if I need to find an equation that goes through this, that is parallel to this line, that means my new line will have a slope of 2/3. If it goes through 3, 3, I'm going to write y equals mx plus b. I'm going to put in what I know. This is y, is the y variable. The slope is 2/3. This is the x, and I don't yet know b. 3 equals 2 plus b minus 2, b equals 1. So my equation will be y equals 2/3 x plus 1, because that's what I just solve for. So that is the equation of the line parallel to this line that goes through this point. Then it says, oh, and a line perpendicular. So when I see the word perpendicular, I'm thinking of the phrase negative reciprocal, which means the slope is negative reciprocal. That green is hard to read. Negative reciprocal. If the slope of the original line was 2/3, the slope of the perpendicular line will be negative 3/2. The reciprocal, flipped it, opposite sign. If this one's positive slope, the perpendicular line is negative slope. If this line is negative slope, then the perpendicular line is positive slope. And the relationship is then the fractions flipped. If it also goes through 3, 3, I'm going to write my equation, y equals mx plus b. Plug in the numbers. The y was 3. The slope is negative 3/2. The other point is 3 plus b. 3 equals negative 9/2 plus b. Add 9/2 to both sides. So 3 is the same as 6/2, so this will be 15/2 equals b. My equation will be y equals negative 3/2 x plus 15/2. And for those of you that opened up that attachment that I sent last week, early this week, I can't remember what day I sent them, with all these slides that were on it, that was the last slide of the 17 in the deck. So now it's an opportunity for you to look back at past homework assignments. I use the word homework now, but that's not really what it is. Check your understanding. It's the work that you're doing on your own free time to make sure you know what's going on. Or from past classes that we've had together, things that we've done during lecture times, for you to ask your questions to me. And while you're thinking of that, reminder too, much like the first exam, you can come with a single piece of paper, front side only, a regular standard sheet of paper, no bigger than 8.5 by 11. So yeah, notebook paper is fine. It's slightly smaller than 8.5 by 11. If you think you need more space, then get an actual just plain, like a number 11 letter piece of paper out of the printer. One side only. Example problems if you want to have them on there. If you do example problems, I would recommend, instead of just having your solution, for every step you have a written explanation of what you did from here to here to here to here to here. So that way when you go back to look at it, in the heat of the moment of having an exam, and you're freaking out and you look at the problem and you're going, I don't even know what I did, because you get yourself stressed out. That's why you put the little words on there that remind you, oh yeah, that's what I did. Like here, there's a lot of work here. You'd be like trying to remember, like, well, what did I do? Where did I start? All right. So I started here. This was my first thing. And then I did this over here. And then from there I solved so that I could get y equals mx plus b. And I'd be putting all these words in there. So then my slope is 2/3. Right. And then I took that over here to parallel with the same slope. And then plugged in the x and the y. And those would be the words that you're adding into the examples that you have. Does it take up more space? Absolutely. But does it make more sense? Oh, 100%. For constant and inverse variation, we did one in class like this, where I said, all right, let's solve it for, like if I solve it for t, that means I'm going to take both sides of the equation and divide by nr. And I'll have t equals PV over nr. And then I would tell you, of course, remember T stands for temperature, N stands for number of moles, or essentially it's like how much there is. of whatever substance you have. P is pressure. R is a constant. Every substance has its own temperature, volume, pressure constant. Oh, V is volume. All right, so in a case like this, you'd say, all right, well, T is directly proportional to P and to V. So if pressure goes up and everything else stays the same, temperature goes up. Which is another reason for those of you that cook in a kitchen, pressure cookers increase the pressure and they add temperature, which allows things to cook much, much faster. All right. Volume. If everything else stays the same and volume goes up, temperature goes up. And some people are like, oh, how do you kind of imagine that one? As things get warmer, they expand, which means they need to increase the volume. If I don't let the volume increase, but I increase the temperature, then the pressure goes up. All right. And then temperature is inversely proportional to the amount of stuff. So if everything else stays the same, if I have a container that stays the same, I want to keep it, but I increase the stuff that's in it. I pack more and more stuff in it. As more goes in, temperature goes down. It would have to go down. And vice versa. If I decrease things, have less and less material inside of something, if I'm removing material, then the temperature would have to go up. As this goes down, temperature goes up. That's direct and inverse relationship. I think we did like a really challenging one to kind of close out the class where it was about pillars. When you're doing concrete, directly related to the diameter of the pillar, inversely proportional to the height. But I think there was like some squares and cubes in there as well. If you find that one, I mean, there's obviously a video that we did on that in class, and so the solution is out there somewhere in one of the videos I did. It's a phrase I said on a different one, completing the square. And I don't think I've covered a lot of these in class. There have been several from your Check Your Understanding that you would have done that you would have used completing the square. But completing the square can be used for, and I'll use that example that we had with negative 16t squared plus 32t plus 48. So the process of completing the square, it's another way to solve an equation. And again, so quadratic formula, looking for factoring methods, factor by grouping, and then completing the square. So completing the square, here's the process, is the first thing you do is move so that you only have variables on one side and numbers on the other. So I'm going to subtract 48 from both sides, and then I'll have negative 16 t squared plus 32t. And then, if possible, I would love it if my t squared was 1. So in order to make my t squared 1, I'm going to divide everything by negative 16. On the left, I'll have 3 equals t squared plus 2t. And here's where it becomes then completing the square. Is I take the middle number, 2, and I take half of 2. And I square it. So half of 2 is 1. 1 squared is 1. And I'm going to add 1 to both sides. I'll then have 4 equals t squared plus 2t plus 1. And here's the reason why. Now I want to factor. And if I've done this right, these will be identical. What two numbers multiply to 1 and add to 2? Positive 1 and positive 1. So then what I have is I have t plus 1 squared. Something times itself is squared, and that equals 4. I'm going to solve for t. I have something on the right-hand side. The whole thing is squared. Inverse of squaring is square rooting. On the left, I'll have plus or minus 2. On the right, I'll have t plus 1. So what I have now is I actually have two equations. T plus 1 equals 2. T plus 1 equals negative 2. Subtract 1. T equals 1. T equals negative 3. So that's an example of completing the square. And again, this can work with any, let's pick one that we don't necessarily know a root of. So if I have, and I'll go back to using x's, x squared minus 10x plus 40 equals 0. And I'm picking one here that's not going to be quite as simple to get to. So I start by the process of get my variables all by themselves on one side. On the other side, I'll have negative 40. That's a 10x. Then I'm going to take the x term, the middle term, the b term, if you will. I'm going to take half of that. So over here, what I'm doing is I'm taking half of the middle term, which is negative 10, and then I'm going to square it. Well, half of negative 10 is negative 5 squared, so that's 25. That goes right here. So I'm going to add 25 to that side. But just like scales, like we always do, if you do one thing to one side, you have to do the same thing to the other side. So then I'll have x squared minus 10x plus 25 equals negative 15. On the left, I'm trying to factor two numbers that multiply to 25, positive, that add to negative 5. And again, if I've done this the right way, it's the exact same thing. That's why it's called completing the square. So this is x minus 5 squared equals negative 15. Take the square root of both sides. I will have x minus 5 equals plus or minus the square root of negative 15. And now, yes, negative 15, there are no real roots, but I still have two equations. So if I were doing the quadratic formula, I'm getting that same process. X minus 5 equals square root of negative 15. My other equation, x minus 5 equals negative square root of negative 15. Add 5, so this will be 5 plus the square root of negative 15. Add 5 over here, x equals 5 minus the square root of negative 15. Those would be the two imaginary roots. I carried it out even though, I mean, if you end up with a number and this ends up being a positive, then you're going to have an actual square root that you can take. Possibly you have to do simplified radical form on it. But completing the square will work every time regardless. Again, just another tool in the toolbox. And if you want me to do another one, I certainly can. All right, we'll do another one the same. Completing the square to solve. Y squared minus 8y equals 34, or 34, put a 0. I added 34 to both sides. And then I take half of the middle number, square it, 16, so I'm going to add 16 to both sides. On the left, this will be y minus 4 times y minus 4, which is y minus 4 squared. And that will equal 50. Square root both sides. Square root something squared, those are inverse operations. I'll have y minus 4 equals plus or minus 50. Square root of 50. I now have two equations. Y minus 4 equals the square root of 50. And y minus 4 equals the negative square root of 50. Y equals 4 minus root 50. Over here, y equals 4 plus the square root of 50. And I'm going to think, are there two numbers, one of which that I know the square root of, that goes into 50? 25. I'm picking 25 because I know the square root of 25, and 25 goes into 50. The square root of 25 is 5, and 2 is prime. So my final answer would be y equals 4 plus 2, 5. Oh, come on now. Oh, I'm on the wrong tool. There we go. 5 root 2. Over here would be y equals 4 minus 5 root 2. And if I would have gone back up to this original equation up here and plugged it into the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, it would have yielded the exact same answer. What we have down here and down here, if I would have run it through this formula, I would have got the same answers. And the completing the square is actually the process by which you create the quadratic equation. Like, that's how it's derived. If you wonder, like, whoever came up with that? They took this original equation, ax squared plus bx plus c, and they did completing the square, and that's what the answer ends up becoming. So the next time we get together, we have the exam. As I've said in the past, for the first exam and for this and for the final, the doors will close and lock at the beginning of class time. So be here early. Early is on time. On time is late.
It's on Tuesday?
It's on the next time we meet. Yep.